The information presented in this training series is intended for true automotive professionals who are familiar with the concepts and tools commonly used to achieve perfect wheel balance. Wheel Balance 301: Understanding Wheel Weight Types. Brought to you by
Perfect Equipment, balancing the future.
When a vehicle is brought into the shop for a wheel balance issue, it is important for the technician to fully understand the options that are available to correctly fix the problem. In previous training modules, we learned that a wheel weight of some type is essential in providing proper static and dynamic wheel balance. But what exactly is a wheel weight and how does it work? Let's start by looking at a cross-section of the wheel assembly, including the wheel and tire. When we zoom in on the top of the cross-section, you will notice several distinct features of the wheel. The top horn is known as the inboard or outboard rim flange. The bottom flat area is known as the front or rear rim spacing. These features of the wheel are the exact location where wheel weights can be applied in order to offset any imbalance. On the rim flange, you can install a knock-on wheel weight, which features a clip that holds it firmly to the rim. Knock-on wheel weights are the most common wheel weight style in use today. On the rim spacing area, you can install an adhesive wheel weight, which features a strong adhesive tape that holds it firmly to the rim. Adhesive weights are increasing in popularity due to modern flangeless rims and their invisible look. Now, let's look at each of these options more closely so that we can better understand their differences. Let's start with the knock-on wheel weights. Knock-on wheel weights consist of a clip and a body. The clip provides the clamping force required to hold the weight to the rim flange, and the body provides the weight mass required to offset any imbalance. Knock-on wheel weight bodies come in many weight increments, from a 1/4 ounce all the way up to 4 ounces or more. Each knock-on wheel weight has the mass size imprinted on the weight body, oftentimes in both ounces and grams. This allows you to select the exact weight needed based on the size of the imbalance. Knock-on weights also come in many different clip styles in order to adapt to the many different styles of wheels available today. The clip style is also imprinted on the weight body, oftentimes in conjunction with the weight material type, such as ZN for zinc. We will discuss that more in just a minute. Each available clip style features a completely different profile that was designed for its specific rim flange application. The first two clip styles, known as the P and the T weight, are for thinner steel wheels, while the rest of the clip styles are for thicker alloy wheels. The MC clip style shown at the top right is the most common of all the alloy wheel clips. When installing knock-on weights, it is important to utilize the correct application for the rim flange you are working with, as this ensures proper fitting and long-lasting results. Installing the wrong application could cause the wheel weight to fall off, resulting in unhappy customers. For many years, only the name was used to identify the clip type. But in the 1980s, Perfect Equipment developed the wheel weight color coding system, which has become the industry standard and is now utilized by all wheel weight manufacturers. The wheel weight color codes can be seen on the application guide, on the product boxes, as well as on the actual wheel weight assortment kit. This allows for faster wheel weight recognition and easier stock management. Knock-on wheel weights are easy to install as they simply clamp to the rim flange when tapped with a hammer. We will learn more about proper knock-on wheel weight installation techniques in our next training module. Now, let's look at adhesive weights. Adhesive wheel weights are made up of small individual segments of material that are pieced or molded together to create a strip of weights. On the back side of the weight strip, there is a strong adhesive tape applied, which is used to hold the weight segments to the rim. Adhesive weights come in varying shapes and sizes, some with small segments and some with large. There are even varying height profiles, including standard and low profile options. You can also find adhesive weights in different colors, including black and chrome, which look great on aftermarket wheels. Every segment on the strip has the segment size imprinted on it, oftentimes in both ounces and grams. This allows you to count the segments to achieve the exact amount of weight needed to offset the imbalance. Adhesive weights come in pre-segmented strips or in large rolls, which make it easier to prevent waste. Some adhesive weights are generally universal. Nearly any adhesive weight will work on any wheel, as long as the weight properly fits the rim spacer area and if there are no clearance issues with brake or suspension components. Adhesive weights are easy to install, as you simply rip or cut the segments to the desired length and apply to the rim. We will learn more about proper adhesive weight installation techniques in our next training module. When discussing wheel weights, it is important to remember that knock-on wheel weights are applied to the rim flange at the location of the imbalance. There are 8 standard clip styles that are made to perfectly fit most wheels and can be identified by color. Adhesive weights are applied to the rim spacing area at the location of the imbalance. And adhesive weights are generally universal and attach using adhesive tape. Although many knock-on and adhesive weights look very similar, they can be made of very different materials. For more than 70 years, wheel weights were made of lead and came in coated and uncoated versions, as you see here. Many wheel weight manufacturers, like Perfect Equipment, have been proactive and are now providing non-lead options like zinc and steel. Both alternatives provide a more environmentally friendly option. However, they do have inherent differences. To better understand these options, let's compare the two non-lead materials side by side, starting with zinc. Zinc is a non-ferrous material that is naturally abundant on the Earth and is identifiable with the letters Zn on the periodic table of elements. You can also identify a zinc wheel weight by the Zn stamping on most weights. Because zinc is non-ferrous, zinc wheel weights are molded and look just like lead wheel weights. The molding process allows zinc weights to better contour to modern rim styles. Zinc has a density of 7.2 grams per centimeter, which means that zinc wheel weights are slightly larger than lead wheel weights, which features a density of 11.3 grams per centimeter. Zinc wheel weights are used by original equipment manufacturers all over the world, including some in North America. This is because zinc wheel weights are typically easier to install and remove than any other alternative. Like lead, the non-ferrous properties of zinc require less force to knock on and pull off. And because zinc is a natural anti-corrosive material, zinc wheel weight bodies will never rust. Now, let's look at steel wheel weights. Steel is a ferrous material that is derived from iron and is identifiable with the letters Fe on the periodic table. You can identify a steel wheel weight by the Fe stamping on most weights. Because the melting point of iron is so high, steel wheel weights must be stamped. This process requires them to have a more straight and rigid appearance, unlike molded wheel weights, which typically have a more contoured appearance. Iron has a density of 7.8 grams per centimeter, meaning that steel wheel weights are slightly larger than lead wheel weights, but similar in size to zinc wheel weights. Steel wheel weights, especially steel adhesives, are preferred by some original equipment manufacturers in North America. However, steel wheel weights can cause scratches and damage to a wheel due to its material hardness, which requires more force for installation and removal. Steel wheel weight bodies must also be coated in order to prevent brown rust. Typically, all steel wheel weights are coated with a zinc-based anti-corrosive coating. When steel wheel weights are uncoated, or if the zinc-based coating scratches, you can end up with severely rusted wheel weights. When discussing non-lead wheel weights, it is important to remember that all non-lead wheel weight materials are not the same. Zinc wheel weights have Zn stamped on the weight, and steel wheel weights have an Fe stamped on the weight. This concludes Wheel Balance 301, Understanding Wheel Weight Types. In our next training module, We will learn more about how to properly install knock-on and adhesive wheel weights, and when you should use one over the other. This training series has been brought to you by
Perfect equipment.